Space, the final frontier. Welcome back to the Comconocave. I'm your host, the Comconocalst, and today we're going to be talking about science. Now, first of all, if you haven't heard, UWINGU has raised all sorts of money for their projects, as well as named over 10,000 different craters on the surface of Mars. Now, if you're not familiar with UWINGU, what they're doing is they're allowing people to name different craters on Mars. You can name it after yourself, a hero, a loved one, a special project. I chose one and named it the Comconocave. It's actually kind of cool. And the names of these craters are actually going to be used in the actual exploration of the planet Mars when the Mars 1 project lands there. They're going to use that as its topographical, map. So if you haven't checked them out, take a look. It's well worth your time, and, it's not very expensive if you want to leave a little bit of yourself behind for history. So check it out. Now, what I really wanted to talk to you all about today was, it's a group. It's called LIGO, I think. It's LIGO. It stands for the Laser Interferometer Gravitational Wave Observatory. Now, what they're trying to do is they're trying to prove the existence of gravitational waves. Now, back in 1916, Albert Einstein's theory of relativity kind of predicted the existence of gravitational waves, but the technology wasn't really available for him to actually prove it. Now, back in 1974, there was a binary pulsar. It was called PRS 1913 plus 16. Now, it showed a lot of orbital decay, and it matched Einstein's predictions as far as the energy loss from its gravitational radiation. So this got a lot of scientists very excited. And the LIGO, I'm not sure how it's pronounced, observatory project came into existence. Now, what it consists of are these two arms that have mirrors at the ends of them, and it's kind of shaped in an L shape. Now, the L's are known as Michelson interferometers, with Fabry-Perot arms at the end of them. I'm sorry, I'm not very good at pronouncing names. Now, there's a pre-stabilized laser that emits a beam of up to 200 watts that passes through this optical mode cleaner, and it reaches a beam splitter which separates the beam, and it passes down both of the arms and reaches the mirrors at either end. Now, what's supposed to happen is when a gravitational wave passes through or by Earth, it's supposed to disrupt some sort of space-time area around the lasers, which causes the length of the laser beam to change in either one or both of the lasers which are being emitted from these things. Now, this is all theoretical. We know that they're out there, but we haven't actually observed them yet. Now, if we were actually able to prove that they existed and, back it up with some hard evidence, I mean, this would open up a whole new area of science as far as astronomy goes. It would open up a whole new area for neutrino observatories, electromagnetic telescopes. It's really, there's nothing that proving that these exist could accomplish. So I'm hoping that, the reason why I'm bringing this up now is because the technology that we had when they first started, I believe it was back in 2002, wasn't quite up to par with what we have now. And this year they've been upgrading all the equipment and all the technology that's involved with it, and they're really hoping that they're going to be able to prove that they exist. So I'm keeping my fingers crossed, just because this sort of thing kind of interests me. So if it doesn't interest you, then I'm sorry you sat through all this. If it does, and you have any questions, feel free to leave them in the comment section below. Or you can reach me at comconocave@gmail.com. And until next time, take it easy.